Hello, everyone. This is the 10.1 problem video. And again, I'm going to start by going through the homework, and if I feel you guys need more examples, then I'll go to the book. First couple questions on the homework are, again, I don't know why they're giving you these first two problems. They give you so number one, they give you an equation, in my case, y equals 4 minus x squared. And then they give you this table, right, with a bunch of x values, like x equals -2, -1, 0, 1, 2. You just take these values and plug it into this equation. So when I plug in -2, I get square root of 4 minus 4, square root of 0, so y is 0. When I plug in 1, I get square root of 3, and so on. Okay, so just plug and chug on the first two. All right. Maybe they're just trying to show that, let's see. So in this one, if you plugged in the points -1, +1, you get the same y values. That's not really interesting. Yeah, I think it's just practice graphing points, basically. Not too interesting. Number 3 is when we start getting to the actual material from 10.1. Okay, so we're given, let's see, and I'll do this one. It's pretty straightforward. Okay, we're given these two parametric equations, right? X equals 1 minus t squared, y equals t minus 4. For t between -2 and +2. And our first task is to graph the equations. Okay, so this pretty straightforward. You just make your table of your t's, x's, and y's. Okay, so let's make our little, let's see, t, x, y. Okay, so just like in the lecture video, I just pick a bunch of t values in this range between -2 and +2. So let's start with -2. When I pick -2 and plug it into my equation for x, let's see, I get 1 minus 4, -3. When I plug it into my equation for y, I get, let's see, -6. Okay, then plug in, let's do -1, I get 0, -5, 0. When t is 0, I get 1, -4. Okay, so I get this table of values, and then I just graph the values and basically connect the dots. Okay, so this would be a rough way to get an approximate view of how this graph looks. So let's see, let's see, I got the point 3, -6, or -3, -6. So let's see. So that'd be like this. Then I got 0, -5. Okay, so that's like here. Then I got 1, -4. So that's like here. Then I get 0, -3. Should be like here. And then I get -3, -2. So it looks like my graph should be a parabola. Maybe this point is maybe that point's the vertex, maybe it's not. Okay. So maybe there's a little ambiguity here. The one thing I want to drive home is that the more points we plug in, the more t values we get, and the more points we find, the more accurate our picture is going to be, right? I could have done like 100 points, and then if I did like 100 points in here, I'd maybe have a very accurate picture of what this graph looks like. It just means more work, right? So you got to balance accuracy with the time you want to spend. But this parabola is a rough idea of what our graph looks like. That should be enough to pick the correct graph from your 4 choices. And then part B is eliminating the parameter. And that really kind of sums up the material from 10.1. It's graphing these parametric equations and then eliminating the parameter, right? Like we have, maybe we have x as a function of y, or x as a function of t, y as a function of t, and we want to write y as a function of x, or x as a function of y. Okay. So part B says eliminate the parameter to find a Cartesian equation of the curve. Okay, so let's remember what our equations are. Let's go ahead and copy these and bring them down. Okay, so these are the Cartesian equations I'm working with. And now I want to eliminate the parameter. Okay. So how do we do that? Basically, I'm going to pick one equation and solve for t. Okay, so most of these problems you could do either way. I would say like try and avoid solving for t in squares, things like that. It's going to be much easier to solve for t in this equation, right? I just add 4 to both sides. Okay, so looking at this, and we don't need these. Okay, so looking at this equation here, I see quickly that y plus 4 equals t. Now I'm just going to take this value for t and plug it into this equation. And I get x equals 1 minus, let's replace t with this thing. I get x equals 1 minus y plus 4 squared. And then I could just expand this, right? So x equals 1 minus y squared, what, plus 8y. And then it's going to be minus. And then plus 16 becomes minus 16. So it should look like something like this. Okay, double check me on this, but that should be our Cartesian equation. And when we write these equations, we don't want to just write this. We want to write x equals. Okay, so you might lose points if you're not writing this whole thing as your answer. Okay, so that would be my answer once I eliminate the parameter. So it's really just about solving for t in one of these equations. And now I've just remembered something I wanted to show you guys in the lecture video that I didn't show you in the lecture video. Solving or eliminating the parameter, gets a bit trickier if these are like trig functions, right? So there's a special trick for that, and hopefully I'll show you guys. I'm not sure it's a problem in the homework, but I'll show you at the end of the video. For now, let's continue on with the homework problems. So that's it for number 3. Number 4, again, just sketching the curve, eliminating the parameter, same idea. Number 5, okay. Maybe this is good to remind you guys how to eliminate the parameter when we have like functions of e. Let's say I have e to the power t minus 8 and y equals e to the power of 2 times t. Okay, so I want to eliminate the parameter. So really these are both, I could solve this either way. I could solve for t in this equation, or I could solve for t in this equation, right? So if I could have two possible answers. I could have like y equals some function of x, or maybe I do it the other way and I get x as a function of y. And both of these should be acceptable, okay? It doesn't look like WebAssign. I've tested out a couple of these and it looks like it accepts it either way. So let's go ahead and solve for t in this equation here, all right? So I want to get t by itself in this equation. So the low-hanging fruit, the thing that's easy to do, is I just add 8 to both sides, okay? Then I get x plus 8 equals e to the t, okay? Now, I want to get t by itself. How do I get this t out of the power, right? I take the natural log of both sides, ln of both sides. So ln of x plus 8 equals ln of e to the t. And if you're comfortable with the definition of log and, natural log and e, you'll see that this ln and this e cancel out and the t comes down out of the power, and I'm just left with t. All right. So t equals ln of x plus 8. Now let's take this value and plug it into my equation for y. Okay. So I replace t with ln of x plus 8. All right. And a nice little trick. E to the power of 2 times ln of 8. That's the same thing of ln of e to the ln of x plus 8 squared, right? Now look inside the parentheses. What is e to the power of ln of x plus 8? Again, if you're comfortable with your e's and ln's, you'll see that this stuff inside the parentheses is equal to x plus 8. And then I'm squaring it, okay? And then you could distribute this, or you could probably leave it as x plus 8 squared. Six, this is a good example. I'll do it both ways. So this is kind of the one that popped out to me. We have x equals e to the power of 3t, y equals t plus 4. Okay, so again, graphing, I'll let you guys figure out the graphing yourself. It's just making that table, eliminating the parameter, okay? So I could, again, do this either way. I could eliminate the parameter here, I could solve for t here, or I could solve for t here. So let's do it both ways and see the two different solutions. Okay, if I solve for t here, I get ln of x equals 3t, ln of x over 3 equals t, and then I plug that into my equation for y, and I'll get y equals ln of x over 3 plus 4. Okay, so that's one solution. Now let's do it the other way. What if I had solved for t in this equation? Okay, I would get y minus 4 equals t. I plug that into this equation, and I get x equals e to the 3 times y minus 4. And then that would be a solution as well. And either one of these is acceptable, okay? All right, these would both be marked correct, but they look pretty different, but they're really equivalent. 7 is not too bad. I'll just kind of clarify the setup. They give you some equations, and then they give you some points. All right, so the points they give me A, B, and C. A is 1, 1. Okay, so we'll call this 1, 1. B is 4, 3. So up here somewhere. C is 1, 6. So that'd be like up here. And then they want, okay, so A, B, and C. And then they want the parametric equations for each of these line segments. So they ask you, okay, what are the parametric equations from A to B? Okay, so how can we write this line from A to B in terms of x equals y equals? And they give you, on the top of this problem, they give you the formula, right? They say, okay, if you want to solve for these, you should do x equals x1 plus x2 minus x1 times t, y equals y1 plus y2 minus y1 t. So just plug these x and y coordinates into these formulas here. Okay, so I'll just do 1. So if we do the line segment from A to B, we would get, let's see, x equals, excuse me, x equals 1 plus 4 minus 1 squared, or excuse me, 4 minus 1 times t. So what's 4 minus 1? That's 3t. So I don't even need the parentheses. I just write x equals 1 plus 3t. And what would my y be? Okay, what's my y1? That's just 1 again. What's my y2 minus y1? It'd be 3 minus 1. So 1 plus 2t. Okay. So that's it. And then you repeat the process. Let's see. So we just did A to B. You also need to do what? B to C and A to C. It looks like maybe they'll give you some different things, but that's the rough idea. Number 8 doesn't look too bad. Just basic graphing, eliminating the parameter. All right, number 9. All right, so this is a good one, and this covers that topic I wanted to discuss: eliminating the parameter when we have trig stuff. Okay, so this is something I didn't cover in the lecture video. Again, the graphing's straightforward, just making your table. Okay, let's eliminate the parameter. So let's say we have, again, this is number 9. So let's say we have x equals 6 times cosine theta in my case, and y equals 7 sine theta. Okay, and we want to eliminate the parameter. So what I can just do is how to describe this. I'm going to use my trig identity, x squared plus y squared equals 1, essentially. Excuse me, we're going to use our sine squared plus cosine squared equals 1. All right, so let's, you might have to play around with the forms. What I would do when you have trig stuff, like trig parametric equations with trig, is I'll try and get the trig functions by themselves. So let's rearrange each of these and get the trig functions by itself. So if I have x equals 6 cosine theta, then x over 6 equals cosine theta, right? And then if I have y equals 7 sine theta, then y over 7 equals sine theta. And now remember the trig identity that always works: cosine squared plus sine squared equals 1. And now just replace these trig functions with these things. Okay, so cosine squared, what's cosine squared? That's x over 6 squared. And what's sine squared? That's y over 7 squared. Okay, so we have x over 6 squared plus y over 7 squared equals 1. In other words, x squared over 36 plus y squared over 49 equals 1. And this is the equation of an ellipse, all right? So that kind of matches with what our graph should look like. So that's it for this one. Let's see if there's anything else. Number 8, or excuse me, number 10. Again, looks straightforward. 11 and 12 look straightforward, just with a bunch of fill in the blanks. And then the rest looks like review. Okay. So yeah, this is the last one I wanted to cover. I wanted to make sure to get an example of this trig stuff for you guys. So hopefully you'll be able to deal with that.